Welcome back. Now we want to solve absolute value inequalities with greater than. Notice, if I say absolute value x less equals 5, that means distance of x from 0 has to be less equals 5. So at the most to the right you go is 5. At the most to the left you go is negative 5, and you have to hang in between these two numbers for your distance from 0 to be less equals 5. On the other hand, what if you want to say absolute value x is greater equals 5? That means distance of x from 0 has to be more than 5. So you have to be beyond 5 on the right and beyond negative 5 on the left. So if equality is allowed, then 5 and negative 5 are included in your set. That's the only difference. So remember, greater equals means you have to be beyond 5 and or beyond negative 5. Therefore, you say x is to the left of negative 5. X is less equals negative 5 or x is greater equals 5. In a more general way, you are looking at, for an expression u, absolute value u greater equals a, well, that means you have to be beyond a or beyond negative a. That is, u has to be less than or equal negative a, or u has to be greater equals a. All right. So for instance, let's look at 2.75. Absolute value x greater than 4. Distance of x from 0 is greater than 4. So you have to be beyond 4 or beyond negative 4. Notice equality is not allowed, so it's parentheses, it's open. In other words, notice this is highlighted, this is highlighted. So you have two intervals, one which start at negative infinity, which is not a real number. So it's open, negative infinity to negative 4. And then you take a break and start at 4 and go on to infinity. When you take a break, you are essentially doing what is called union. Union means you're taking more. In English, this represents or. Let's try a few ourselves. You're looking at absolute value x greater than 2. So this is exercise 2.149. You're looking at absolute value x greater than 2. So distance of x has to be more than 2 from 0. What does that mean? It might help to draw a line first. That's your number line. So distance of x from 0 has to be more than 2. You have to be farther from 2. That is, you have to go beyond 2. Likewise, you have to go beyond negative 2. So, is negative 2 included? No, it is an open point. There is no equal. Is 2 included? No, it's an open point. Further, x is beyond 2 or x is beyond negative 2. So the way you write it is, you say x is less than negative 2 or x is greater than 2. That less than negative 2 takes you to this interval. So that's negative infinity to negative 2 open. That or becomes union. Union is simply u. And this piece, which starts at 2, open because it's not included, it's open to infinity. That's it. Let's try one more. Absolute value x greater than 1. So this is exercise 2.150. You want to understand absolute value x greater than 1. So this gives you, start with the line if needed. Anyway, you have to graph it. But geometrically, it's easier to understand what's going on. Greater than 1. So somewhere here is 1. Greater than 1, you don't want 1. Distance of x is greater. Distance of x from 0 is greater than 1. So x is to the right of 1. Furthermore, distance of x is greater than 1 means x could be here as well. You see, x could be here or x could be here. That's all you want to say. So you would say x is in this world. So x is less than negative 1 or x is greater than 1. So x could be here or x could be here. That's all you're saying. So in the form of interval, this means you start at negative infinity, open, until negative 1, open, that or becomes union, that is u, 1 to infinity, open. Open because they are not included, so they are open points. This u stands for union. This u stands for union. All right. Let's continue in our next video solving inequalities with greater than or equal